Hi, my name is Ryan, and I'm from Amador Valley High School. This is my third milestone in completing the gesture-controlled robot. Last time I was here, I had the Bluetooth working with the forward move method for the car, but now I've gotten all the move methods to work with the Bluetooth, and I've also implemented 2 ultrasonic sensors so that the car can stop when motion is detected in the front or back of it. Let me show you the code that I used. Yeah, okay. Okay. So I'll start off with the ultrasonic sensor. I use the same method essentially for both of them. So I'll just show you the method I used for the ultrasonic sensor in the front. Okay. So first I use the trig pin on the ultrasonic sensor to send a signal. And then I use the echo to receive that signal. The raw data that I get from this, imagining there's an object right here, would be the distance to this object and back. So first you need to divide that value by 2, and then you need to multiply by the speed of sound in whichever units you want. I used centimeters. That would be this operator here then. And then I'm printing the distance, and then in this statement here, I determine whether an object is close or not close. So if it's like this far, 15 centimeters, or I found if you cover both eyes completely, it jumps to 1180. So in case the 15 doesn't work for some reason, um, if that is the case, then it will return true, and also it will return false. And again, this is because it's a Boolean method, right? So it returns true if an object is close and false if an object is not close. And then down here, I implemented it in my loop. So first I'm just reading the Bluetooth values that I get from here and just a little understanding of that. I worked on it mostly in my last milestone, but on the Arduino Nano, this is the logic statements for using the MPU 6050 access accelerometer to determine what orientation the chip's in. Depending on the orientation, send a char relating to the direction, and then the Arduino Nano picks up the direction in this switch and case statement, and then depending on the direction, it'll invoke the direction of the car, the direction method for the car. And then I added the ultrasonic sensor methods in here. So I first said inside the forward case, if not ultrasonic, and remember, ultrasonic will return true if it's close and false if nothing is close. So if not ultrasonic means if there's nothing in front of the car, then move forward, else stop, right? And the upside to coding it this way is that if there is indeed an object in front of the car, it won't be able to move forward, but it will be able to move all the other directions to get away from that object. And the same logic is here implemented with the backwards move method. And then for all the directions, I just changed the voltages that I was sending to the different motors in a different sequence. And you can see that right here. Stop, coast, turn right, turn left, move backward, move forward. Now I'll give a quick demo so you can see the ultrasonic sensors as well as the directional methods in action. Okay, so I'm gonna have it move forward. Oh, sorry. Oh, the car's reversed. Right, so I'm gonna have it move forward. And this is the ultrasonic sensor sensing there's something in front of it and not being able to move forward, like around that 15 centimeter mark. Okay, now I'm gonna have it move backwards. And you can see I'm doing nothing different with the controller. Okay, and then I'm also gonna have it turn right, and then I'm also gonna have it turn left. So those are the directions working. Some of the hard parts about this are the fact that Uno actually doesn't have enough voltage ports as well as ground ports for these 2 ultrasonic sensors. So I had to attach an external breadboard to ports on the Arduino, and then I had to map those ports to the ultrasonic sensors. So just a little more wiring required. It makes this all a little more hard to fix if there's a problem. And then I also had to learn how the ultrasonic sensor worked in the first place, which I explained to you in the beginning of this video. And I also had to figure out how to use it, like the echo and trig pins and the specific methods that I'd have to use in Arduino IDE to invoke them. This is my progress so far. I've essentially finished the base of the project. In my modifications video, I hope to show you how I can use a joystick as an alternate control method to the gesture control, and how I can be able to switch between the gesture control and the joystick control methods on this controller. Thank you.